All right, so stuff we should know, but may not quite have fully embedded in, perhaps is the domain and range of functions. So just a quick review. Just put it here because I want both screens on the video. Domain are the input values. They're the inputs and they are x. They are the x values. The range are the outputs of a function. They are the y values. Remember what a function is when it's represented on a graph like this. It's all the answers sometimes between a certain number of x's. So for this first example, this is all the answers for this function from -4 to 3. How would I write that? Domain of function A of A on screen. -4 up to 3. Now I need to put those signs in. If I see an open circle like that, that means it can't be -4, but it can be minus the one right before that. So -3.999, etc. So x is just going to be bigger than that. X is getting bigger going this way. But it stops at 3. And that is between -4 and 3. Now that is the domain of A. The range of the first one on screen is the output values. And that's where we look at the y-axis. Domain, you're looking at x-axis. Range of the first one, the lowest value, I think, is -2. Remember, when you're looking at a point like this, first value is the x, second value is the y. First value is the input, second value is the output. Matthew, you with me? Yeah. So the y values can go as low as -2 and can equal -2 because it's a heavy circle. Remember, it's not that circle. It's less than or equal to. And the largest value is 4, but I don't put that in. Don't put the equal to bit in because it's an open circle. So look for those open and closed circles. Domain. Right. If there is no limit to the domain and range, as in arrows in both directions, how do I write that, Valentina?
Like real number, like
yeah. X is an element of more. X can be all real numbers. E for element, or for real numbers. X can be all real numbers. There's no restriction. It can be all fractions and everything. And Y would be the same. Y an element of 4. Okay. Sometimes these functions have breaks in them, which we looked at yesterday, and they're asymptote. How do I, if there's an asymptote, how do I just show that in the domain and range? We did this briefly. Start, Tisha. Yeah, so x cannot equal a certain number, so 4 or something. If there's that break in asymptote, the dotted line, that's how it's represented. So you'd say x is an element of or, and then you'd also put in this as a provider, just comma, x can't be 4. X can be everything but 4. It's an example. That's not related to the second graph, which I'll do now. So the second example, B, that's something we call a cubic function, which we'll recognize these graphs as we get better at them. The first one was a linear, a straight line. Anyone care to suggest what the domain might be in that first one? We're looking at the x-axis of this domain. What's the smallest value it can be is the first thing you should think. Is there a stopping point? I think there is. I think that's a solid circle here. So that's the stop. So the line you can't really see. I'll pull you back a bit further. Smallest value for x is 3. I think it's -5. Yeah, remember, look at the x is always the first term in the bracket. Just look at the smallest number.
So I was thinking at the top.
Yeah, you were looking at y. That's okay. So what, -5 is the smallest. Can it be equal to -5? Yes, because it's got that full circle. What's the largest value x can be? It's an arrow. It goes on forever. Okay, so there is no restriction at the other end. So x is just greater than -5. You can write it the other way around if you want. X is greater than or equal to -5. Either way, it's the same thing. There's no restriction. You don't put in an infinity symbol. No need for that. Just it's greater than -5. It's everything greater than -5. Y then, so that's the main for A or B, and the range for B then is the lowest value we see for Y on screen. That was the smaller one. -145, yes. -145, and the largest value is also shooting off into infinity there at the end. So y is going to be greater than -145. You can write it the other way around if you want as well. So there's no restriction. You just need to say what's the lowest one, and then that's it. There's two examples.
Wait, sir.
Yeah.
That's what we will have to do.
Yes.
Oh,
Have to be able to state the domain and range when given a function's graph. That's one thing you have to do. Yeah, let's move on. We'll review another skill that we need to do was if given a function, no graph this time, you're just given the equation of the function, can we substitute into it? Should be able to. So if we're given a function, can you substitute into the function? So part A asks us, okay, that's the function with x in it. I want the function with -3 in it, and that's how it's in. Function with -3 in it. So each of these x's becomes -3, and there should be a value, an output. 5 times -3, so I've replaced the x with -3, minus -3 squared. So both those x's have been replaced with -3. And then it's just a calculation. 5 times -3 is -15. -3 squared is +9. And minus plus 9 is -9. Yes. And subtracting these, I should go back way back to -24. If I wanted to plot this on a graph as part of a function, I could. It would be this point. -3 was x, the output was -24. Input, output, part of the domain, part of the range. They didn't ask that question, but I should have. Remember, in brackets, that always the x value, and that is always the y value. In part B, this time they don't want x replaced with a number, they want it replaced with a letter, and they want it replaced with a negative x. So every time there was an x, we substitute in negative x into the same function. And do put it in brackets, just to make sure you don't make any mistakes with negatives. 5 times negative x, negative 5x. Negative x squared is positive x squared. And then minus plus x squared leaves minus x squared. It can't do anything more than that. That is the case. That is the answer. If I sub it negative x, this is what I get out. Still don't know what x is. Just change the function slightly. So that was subbing in individual and either variables or numbers into a function. The next thing was substituting in functions into functions. What was that called again?
I was just
Yeah. Thank you. What was it? Inverse? No, that was when you're looking for the opposite function. It was inverse. exactly what Constantine just said. Nobody knows? Okay.
Absolutely nothing.
No, that's where it's turns all things positive and negative. It is further back than that. Look at your notes. It's composite. Composite functions. Subbing a function into a function is called composite functions. This is composed. Okay, so this is one function. Second function is the question that's on screen. And the first question asks f bracket g bracket x bracket. Right. Jaden, explain what we need to do here.
So we have to extract.
Yes. Not quite, Sponsian.
First of GA. With an x by 2x plus 1.
Okay, so that's the gx function, yeah. Yes. So this says to substitute the g function into the x function. The g function on the inside, it replaces the x in the x function. That's. So it's the f function with the g function in it. Which means I replace this x, 2x plus 1. That's that x replaced. That's what I squared. And I replace this x, 2x plus 1. And then I just subtract 2 at the end. So those used to be just x's, now they're 2x. They've got a function in instead of x. Also just substitution, but a little bit more difficult. Should be able to square this with our knowledge of quadratics. Yeah, what's the square? 2x minus 1 squared is
4x squared
Yes.
plus 4x.
Yeah. So that'll be plus the 2x plus the 1, the plus 1 affect those. Simplify this. Keisha, can you help me simplify this? I'll start it for you. It's 4x squared. It's nobody's. It's only 4x squared. It's only 1 squared there. Yeah. That's it. Yeah. And to tell you up because plus 1 is 2. 2 taken by 2 is nothing. Often, let's put it up here. They ask you to sub a function into a function. So in this case, gx into gx. So written like that. So for this one, this is part B on screen. You don't need the fx function anymore. Gx function, you don't need to rewrite it. I just do out of habit. The gx function is that. I need to put it in. That's the answer. And the output, I put it in to the gx function what it was originally. So that's now 2 times 2x plus 1 plus, which will give me 4x plus 2 plus 1, which gives me 4x plus 3, and this is this new function, g, some people say g after g of x, but it's the g of x function subject to itself. These are called composite functions. When you sub functions into function, you can get that continued. Sometimes you can see something like this: g of x subbed in, g of x subbed into f of x subbed into g of x. You keep going. You can keep subbing the answer into the next function, keep subbing that answer to another function, and go on forever and ever if you wanted to. Generally, in this course, it doesn't go beyond 3, and you rarely see it. Can. So you just sub this answer into the fx function or whatever. Keep going. Okay. What else? Tell me something about this. graph that's on screen. Good. Infinite, the domain and range?
Yes.
Yes, I suppose. Well, I'm not sure the range or the domain might be infinite. Like these, won't go any further in mind. I don't think these are coming back. What is it not? Well, it's got a quadratic shape that's on its side. It's but it's not a fraction either. What is it not? Gabe, what is it not? You don't know what's not? Valentina? It's not what? It's not in the line. Somebody's saying something online. Jack, what is it not?
It's not a function.
It's not a function, yes. Why is it not a function, Jack?
Because a vertical straight line meets it twice.
Vertical line test. If I can draw a vertical line through one of these graphs, so a straight line down, at any point, and it hits it more than once, it's not a function. Something called just a relation. There's a relation. These numbers can be relations. This might be part of a circle, or well, it won't be a circle, but it's got some sort of form to it, but it doesn't pass the function test. Function must have unique inputs. Can't have the same input twice to give two different outputs. So the vertical line test of like if you draw a straight vertical line and it hits the graph more than once, it's not what we call a function. It is a relation. Okay, so that's key. So quite often you'll be asked, is this a function for 1 mark? And you just say yes or no. And it'll be based off some sort of vertical line test. It can also be used for the inverse. It's that as many as you want. Who's good? Yes, perfect. Yeah. You. Yes.
But why do we need to do it? It's not a function.
Why do you need to know? It doesn't apply very much in real life to what you're doing, but for this unit, you need to know if it's a function or not. And if it's a function, we won't be able to solve it a lot of times. We can't solve functions. We can't get x answers out because there's more than one x answer. It's a good question. Okay. Using technology to draw graphs. What shape would this graph have? Anyone know in general? It's got that fraction in it. It's got the two things, yeah. Yeah. So we looked briefly at shapes of graphs. I think we did a whole lesson on shapes of curves and stuff like this. This is a reciprocal or a rational function. So hopefully you have your calculators today. So the one on screen, it should have this kind of shape to it. It has two areas that the graph kind of sits, and those areas are partitioned off by unseen lines on your graphing calculator. Those unseen lines that they do never cross are called asymptotes. They should be able, at this stage, able to plot this on a graphing calculator. Anyone not have a graphing calculator today? How do we do this? We'll go through now. Okay, so a few of you have missed out doing this already, so I'll do it one more time. Vertical line test I will remove. In your graphing calculator, you should start off by pressing the y equals button. graphic calculator, we'll turn it on first. So you should find a y equals button at the top. We should have y1, y2, y3 all down the side. This is where you put in this function. Because remember, y equals is the same as fx and y the same. How do we put it in? I would start off by putting a bracket. Because I want to do 4 separately divided by bracket. So this is a division sign, so just press divide on a calculator. X plus 3 bracket. Where's the X button? It is below mode. It's that link xt mega n. Press bracket again, close up. So I'm on 4 divided by x plus 3. And I subtract 1. That's what I type in. The y1. Once I've done that, I press the graph button, which is in the top right corner of the screen. I'll do this now. If you're online, you can see my attempt. It should look something like that. And you see it. Sure. You'll see on your screen that the x-axis there and the y-axis kind of goes through it. From this, Alicia, say, okay, show me yours. Good. Good. Oh, you have loads of stuff here. Needs to get those. Anybody else not work? Okay. 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 Next one. I'm just going to set your scale as 10, 10, 1, 10. Oh, you put it in that's this. Anyone else need help? Sure. It's good. Sweet. Didn't need to drop it down there. Yep. Yes. You can't see it all here. So you want your x minimum in the negative, so you see the negative part of the graph. This graph again. Okay. All right. So from the graph, you should be able to read a couple of things. The main 2 things you're looking for is where it doesn't cross. These 2 lines, where doesn't it cross? This one should maybe think about what do we think it is? The asymptotes. Valentina? X equals 3. Doesn't look like x3 from the graph, does it? Looks like it's before it's in the negatives. So if you look at it, you can kind of think, I think it's around -3. And that would make total sense because -3 plus 3 means a division of 0, and that's exactly what you're looking for. So x equals -3. An asymptote is a line, so you write it as such. That is the vertical asymptote. It's a straight line down here. That one. Y equals then, I think this y equals is slightly below the axis, isn't it? It drops down below it. How far down below it? Exactly 1 unit below it. Because if this -1 isn't here, it's going to be just the y-axis, but this -1 brings that down, or the x-axis just brings it down 1. So the actual dotted line, I think, would be around there. So you have to kind of, in conjunction with your function, understand, and in general, dividing by 0, for instance, if it was just x, it would be at 0, but if it's x plus 3, I need to make it 0, so it's -3. In general, if it's over anything, it'll be y equal to 0, but if it's -1 at the end, it just moves it down to -1. So you should be able to perhaps do it off both, looking for those lines, the graph won't. But you can just read it off the calculator and estimate. It's around -3, and hey, the number in the question has +3. It'll be a whole number for you guys. Okay, so that's rational functions, how to read, graph, and draw it. How do we draw absolute value functions? So once again, this would be using your calculator, some calculator instructions. Clear your previous one, so that'll be just press clear on your y equals. Yep. Once again, you go to your y equals button. This time, you gotta, when you're in that, go to press the math button next. Just press the math button. Then press the right arrow to get the number. One number, it's not a button, but you press the right arrow to get the number. And then press number 1 or enter on ABS. You want 1 ABS, press enter on it. And it should bring you back to the y equals thing with a flashing box in between this. In between this, type in x minus 4. Type this in now. Press enter and graph it. Press that graph button again. And you should see a straight line graph in your thing that bounces off the x-axis. Where does it bounce off the x-axis? Alicia? Exactly. Why does it bounce off at 4? Well, because 4, take away 4 is 0. And that's the only time it's going to be anywhere close to negative. The smallest value that graph will ever have is 0. But every other graph, every other value is positive. But that's what absolute value does. Changes all negatives to positive. Okay. And yesterday we did final thing, just inverse. So try and do these two if you. While I just move that position. So find the inverse one from these two. This function, and an inverse of this. So try and lead me to it. Remembering our steps from yesterday, if you're here. Don't need a calculator anymore. So I want to find the inverse of this. My steps. I'm trying to remember them now. This is the question, the answer. I would start perhaps with rewriting it in y and x instead of fx and x. If you've done the first one, do the second one. If you've done them both, just bear with me for a second. Check manage back for the classwork and get onto it. Swap the variables was the second step. So every time it's an x, write y. Every time it's a y, write x. And then solve it for y. So I'm adding 1 to both sides because I don't want this one. I'll also remove the 4 in a minute. And x plus 1 is equal to 4 times y. Divide by 4 to get rid of the 4 times y. and I have x plus 1 divided by 4 equals y. Final step, rewrite the function with this terminology. F minus 1 of x, which stands for inverse, is x plus 1 divided by 4. It's the same answer here and there. Does that answer make sense to me? Yes, because the original function subtracted 1 and multiplied by 4. My inverse adds 1 divided by 4. Should be the opposite operation. Second example, the gx function, the inverse of this is a more difficult example. First step, rewrite in x and y's. Second step, swap the x's and y's. Third step, solve for y. Get rid of this hopefully. My previous answer. To get rid of a fraction, y plus 3, I need to multiply both sides by y plus 3. This goes cancel out that, which is what I want. But this needs to multiply both. So I have xy plus 3x. Both are multiplied by x equals 1. Now what I'm trying to do is trying to solve this for y. So I don't want this 3x on this side. I just want to isolate y. So get rid of it first. I have xy is equal to 1. Take away 3x. And I still want y on its own, so I divide by x both sides to get rid of that. X. Y is 1 minus 3x over x. Final step, rewrite it with the terminology. Inverse function is 1 minus 3x divided by x. This one perhaps is not quite as easy to see the inverse by looking at it. 1 over x plus 3 turns into 1 minus 3x divided by x. It's obvious. Okay. Oops. So yesterday you were working on these. I expect to see at least 5 parts from question 1 done. If you've done 5 parts from question 1, I want you to move on manage back. Oh, not that. It's so there's some quadratics. Because quadratic functions are a huge part of this unit. So we've done solving quadratics. If you want to try those, that's factorizing and all that stuff. You can move on and practice those before we do it tomorrow. So at least where we was going forward, we're doing a review of that. At least 5 parts from this. If you've done more than 5, you can do a few more, and then move on to manage back and practice your solving quadratics. We're moving on to that tomorrow. It only is going to be at least 5 parts, and I'm sure you can do that. So these are all inverse functions. Follow the steps. First of all, write out the y and x's, swap the x's and y's, and then solve them.
That's the inverse function.
You can say just there.